your microphone too with your point.
Mist rising over there.
I saw that mist.
It's crawling up the...
Yeah, you can see it coming up the wall. Good morning, I'm Ferry. I'm Public Affairs Officer for the Bureau of Reclamation, and welcome you personally to Glen Canyon Dam. It's the principal unit of the Colorado River Storage Project. It's a facility we're quite proud of, and we're quite proud to be part of the adaptive management program that's taking place.
Presentation by our director of the U.S. Geological Survey, Chip Grote. And then at 9 o'clock, we're going to be departing for the bus. We'll go down to the base of the dam for the second release of water. And at 1 o'clock, we're going to be down at Lee's Ferry with our research crews. They're going to be getting their boats ready and actually testing equipment and things. And without further ado, I'd like to introduce our director, Chip Grote.
I think probably the most significant part of the impact and effects of Glen Canyon Dam on the system that we'll talk about today and that you'll be seeing the effects of relate to the fact that since the dam was built in '63, 93% of the sediment that normally would have flowed down the river has been trapped behind the dam. And it's clear that sediment, sand, mud, silt, plays an incredibly important role in the ecosystems and the natural systems of the river. It builds bars, it builds beaches, it covers up sites of cultural interest, it provides habitat for fish of various kinds. And so how much sediment and where it is in the lower part of the system here below the dam is an extremely important part of the Colorado River system. So what we're seeing this morning and beginning this morning is the Bureau of Reclamation having opened the dam's bypass tubes, and that'll continue for 90 hours. But the peak flow will occur for 60 hours, and that's at a rate of about 41,000 cubic feet, a little below what was at 96, but it's at about 33,000 cubic feet per second above what the base flow has been for the pre-test flow for the past few days. So that's a significant increase. One of the reasons the shorter duration flow is important because we learned in '96 with a much longer flow, about 7 days, that the sediment that has accumulated in the system is moved out early in the process and is distributed in the positive environments they're trying to put it in fairly early in the process. And once you've done that, then if you continue with a high flow for a longer period of time, you've got much clearer water, and that water tends to erode the sediment that you put there. So the plan is that the shorter duration flow will put the sediment in the right place, and by bringing the flow back down and after a short period of time, it will not be eroded by that flow itself. And this is really going to help us determine if the flows that are being put in the river by this process are going to distribute the sediment that's been brought in by the tributaries below the dam, principally the Ferry River, to build back some of these bar, beach, and backwater environments that are so critical for recreation. They're so critical for the physical aspects of the river, and they're critical habitats for fish and for some of the land-based fauna and flora that are down there.
With that, we'll go ahead and start heading for the buses. I might, as long as we've got a second while we've got everybody here, let you know a little bit about what you'll be seeing. Lonnie Corley is the head of the operations for the power plant here. Lonnie, as I understand it right now, the two tubes that people have seen running are carrying about 1,800 cubic feet per second. Is that about right?
That's correct. They're running about 1,800 cubic feet per second. And the two tubes that we open will be 3 and 4 this morning at 10. And they will add an additional 1,800 cubic feet per second to the river as we ramp up for the rest of the day. Every 3 hours until 4 a.m. tomorrow morning, the river will be at the full capacity flow of 40 to 41,000 CFS.
So when you see two hands up, we're within 15 seconds of opening the tubes.
Hey, you.
As long as you don't have burning.
emphasize that I encourage you to head down to Lee's Ferry for the 1 o'clock program, because that's really what this is all about. The focus is on how the water is being used and not the water itself.
Look how close the water is to the cable. Isn't that something?
It's coming up. It's coming up. Exactly what's happening.
We're going to be carrying out about 20 experiments with this flow, and the river will literally be lousy for scientists below the dam over the next few days.
And then you raise it back up, and as it comes back up, it collects water through the little nozzle there, and you use it to measure the amount of sediment in the water column.
What's actually being measured here?
Mostly sediment. We're looking at what the grain size distribution is, the size of the sediment on the bottom of the river, in the water column, and also the concentration. So we're looking at grain size in the water column and on the bed, and the concentration of sediment in the water column.
Okay.
Don't be shy. Anybody can do this.
So there's several questions that we hope to answer by this flow. Again, principally related to the sediment, its distribution, its presence in the water column, its presence on the land, its duration beyond the flow, how long it stays there, and whether it goes where people hope it goes, and whether it has the presumed effect.